My name is Nicole Little. I'm a physical scientist that does inorganic chemistry at the Museum Conservation Institute in Suitland, Maryland. At MCI, we use a variety of analytical techniques that are commonly used in industrial applications and academic research, but we're using those tools specifically to understand the life history of cultural artifacts and objects and artwork, as well as understanding the processes that are happening that are causing degradation of those objects. My field and work at MCI can be a little bit difficult to describe, and I'll tell you why. So, I can be asked any number of questions from any number of disciplines any day of the week. I could get a archaeobotanist one day asking me a question. I could get a paintings conservator the next day wanting to identify pigments in a 200-year-old painting. And then I could get a physical anthropologist the next day that wants to look at the health of the Danish population in the 80s to look at their bones. I could then the next day have a marine biologist wanting to know what we can tell them about seashells and nautilus shell growth. All of those disciplines work at the Smithsonian, and we help answer all of their questions. Part of my role at MCI is to help people form their questions and also determine what analytical tools are appropriate to answer those questions. At MCI, I work with ICP-MS, which is inductively coupled plasma mass spectrometry, and XRD, which is X-ray diffraction. ICP-MS is a highly precise technique that can analyze for very small traces of elements in any number of objects or samples. If you can take a sample, digest it in acid, run it through the ICP, you can get very precise elemental information on that, and that can help you with any number of questions. Things I've worked on there have been analyzing bones to look for heavy metals, for health and status of a population, or looking at obsidian to look at the source and provenance of that obsidian. X-ray diffraction is a technique that we use to identify crystalline compounds. And crystalline compounds can be in painting pigments or any number of artwork materials, minerals from rocks. If you're trying to identify what specific compound is in a sample, we can do that with X-ray diffraction. XRD can also analyze for corrosion products, which is usually a very good indicator of the degradation of a product. If something is creating one corrosion product, it could be perfectly safe. But if it's creating another corrosion product, it could be damaging that object, and XRD can help us figure out which one is happening. I recently worked on analyzing soils from Angkor Thom Temple Center in Cambodia, Siem Reap, Cambodia. And for that project, we've been analyzing soils to look at heavy metal content to determine where bronze workshops were being used on the site. And that's something that I'm passionate about because it involves environmental contamination as well as archaeological research. I think I love what I do most because I love problem solving and working with my hands and helping people. And this job has really developed my abilities to problem solve with how many complex questions we get, as well as helping people in ways that I never thought that I could before.